Welcome back to Manish Kumar channel. So today we are going to see an example of multivalued function. And in the previous video, we have already discussed about the multivalued functions. Now in this video, we are going to explore how one can see the multivalued function in W plane, right? In a very quick manner, you are going to learn how the plotting can take place and how we are going to make them into a single valued function. Consider the transformation W equal to ln of z, then show that the circle with center at origin in the z plane are mapped into lines parallel to v axis in W plane. Okay. The second part, rays from the origin in the z plane are mapped into the lines parallel to u axis in the W plane, right? And then last part, the z plane is mapped into vertical strips of width 2 pi in the W plane. Okay. Solution. So we have W equal to U plus IV, which is equal to ln of Z, and ln of Z can be written as ln of R plus I theta. So here we are considering only principal argument, right? Okay. You know the general form ln of R plus I theta plus 2 pi k, where k belongs to integer and this is your argument only. Okay. So when k equal to 0, we are going to get the principal branch. Okay. So in that case, we are comparing real and imaginary part. So we are going to get ln of r equal to u and v equal to theta. So if you see ln of r in W plane, so we are going to get a parallel line, right? Which is parallel to v axis. So here, modulus of z equal to r will produce a circle with center 0, 0 and radius r, right? So as long as r is increasing, we are going to get concentric circle, right? And each circle are mapping to the lines, right? So we are going to get multiple circles which are going to map to the multiple lines parallel to v axis in W plane, right? So this is going to be a transformation, right? Fz equal to ln of z, right? Which is a multi-valued function, right? So the second part, rays map to horizontal lines. And as you know, this is the origin, right? From origin, any line, if we consider this dashed line, blue line, right? Let us call it as 1, line number 1, line number 2, line number 3, line number 4, right? And if you see the angle we are going to take here, pi by 6, let's say, and this is also pi by 6, right? So what had happened, this is going to be 2 pi by 6, which is equal to pi by 3, right? So now if you see these angles, so this is basically your theta, and z equal to r e power I theta, right? So what had happened is r is your radius, right, from origin, and theta is the rotation, right? So these are the lines actually. Okay. And then in that case, when we are going to take the ln of z, when we are applying ln of z, so ln of r e power I theta we are writing, which is basically ln of r plus I theta, principal branch we are considering, right? So now, so see here, if you map the rays, right? So this will map parallel to, because every alpha, if you see theta equal to alpha, so alpha equal to pi by 3 and pi by 6 and so on, map horizontal lines in W plane with equation V equal to alpha. So this will be the line 1 map, this will be the line 2 map, and if you see here, there is a big gap between these two lines. So the gap appears here. So line 3rd and line 4, right? As long as theta is increasing. And when you go theta in this direction, right? So because principal branch lies between minus pi to pi, so lines will come down also, right? Like that, like that. Okay. So part third, vertical strip mapping. So the entire z plane map into the vertical strip of width 2 pi in the w plane. So what had happened is, we have seen already the entire z map. The entire z map will looks like, if we are considering this z map, right? And if we are going to take the circle, okay, and then this is your y, this is your x, this is your imaginary axis, and this is your z plane. Okay, so what had happened is, and this is your r dashed line, right? Different dashed line and so on. Okay, so what had happened here is, this map to, this lines map to, you know parallel to u axis. So if we are going to consider the principal branch means this is origin 0 comma 0, right? So principal branch means here minus pi to pi, right? So here, if we are going to consider another sheet, so second branch, if we rotate, and another sheet, third branch, and so on. And these rays are going to be the parallel lines, parallel to you. These circle will map to the horizontal line, right? Which we have seen already. So this is going to be ln of r, and this is mapping your phi equal to alpha. So this is your angle alpha, right? And this is your z equal to r. This is your r radius. So basically, your entire plane, z plane, is going to map into the sheets, right? And in this sheet, this is the principal branch, and gap is, if you see the gap, if you measure the gap 2 pi, the gap between each sheet is 2 pi. This is very important, right? In each sheet, if you see, in each sheet, the function is single valued, right? So this is single valued, in this single valued, in this single valued. Okay. So since it was multiple valued, and the integer k belongs to z, so you are going to get infinite sheets. How many sheets? Infinite sheet. Due to infinite sheets in Riemann surface, we are going to call this function as multi-valued function. So this is very important and very interesting example in complex analysis. So thank you very much for watching. Thanks a lot.